Hey everyone, welcome. Today we're jumping into a really fascinating intersection: generative AI, cybersecurity, and ethics. And here's the big idea I want us to keep in mind. Capability creates value, but governance makes that value trustworthy. GenAI can create, cybersecurity can protect, and ethics can guide, but none of those works brilliantly in isolation. Think of this deck as an equation. We're asking not only, what can the technology do, but also, how do we secure it, and how should we use it? We'll build the technical foundation first, explore what GenAI changes in cybersecurity, and then tackle the human questions around responsibility, fairness, and control. So, let's unpack the equation. Okay, this slide gives us the whole chapter in one picture. We have generative AI creating new possibilities, cybersecurity protecting the environment, and ethics helping us decide what responsible use actually looks like. Now, notice the overlap in the middle. Responsible innovation. That's the sweet spot. If we chase capability without security, we create exposure. If we focus only on security but ignore ethics, we can still build systems that are unfair or intrusive. And if ethical principles never become real controls, they stay as good intentions. The exciting part is that these three domains can reinforce each other. Better governance can inspire safer design, and safer design can make innovation easier to trust. Next, let's zoom into the technical stack underneath GenAI. So, where does GenAI actually fit? Let's work from the outside in. Artificial intelligence is the broadest category. Machines performing tasks we associate with intelligence. Inside that, machine learning allows systems to improve by learning from data and experience. Go one layer deeper, and deep learning uses multi-layer neural networks to understand complex patterns in text, images, audio, and more. Then right in the center, we get generative AI. Its special move is creating new content from those learned patterns. And here's the important pause. GenAI inherits everything around it: the power, the dependence on data, and the limitations. It isn't magic floating above the AI stack. It's the latest layer built on decades of learning technology. And that context helps us understand both its promise and its risks. Here's where the story gets really interesting. Traditional AI is fantastic at analyzing what already exists. It classifies, predicts, detects patterns, and supports decisions. GenAI adds a new gear. It can generate, simulate, and imagine possibilities that were not explicitly there before. In cybersecurity, that means moving from what happened toward what might happen next. A system can help create attack scenarios, synthetic data, customized responses, or new defensive ideas. That's a huge shift from analytical to creative and proactive. But creation cuts both ways. The ability to generate useful content can also generate convincing scams, misinformation, or malicious code. So the takeaway is not that traditional AI disappears. GenAI extends it, and with that extra capability comes a much bigger responsibility to test, supervise, and govern the output. Let's take a quick ride through more than 70 years of AI history. In 1950, Alan Turing challenged the world to think seriously about machine intelligence. By 1956, the term artificial intelligence had a name. Work on backpropagation later helped make neural network learning possible. Then Deep Blue's 1997 chess victory showed that machines could outperform humans in a complex strategic domain. Fast forward to the 2010s. GNs arrived, AlphaGo demonstrated the power of deep learning, and the GPT era pushed content generation into everyday life. By 2024, multimodal systems were working across text, images, video, and productivity tools. Now, pause on that acceleration. Decades of foundation suddenly turned into rapid, visible change. That speed is exciting, but it also means our security practices and ethical thinking have to evolve just as quickly. Now, let's bring this directly into cybersecurity. The loop starts with observation, network traffic, system logs, and user behavior. AI helps detect anomalies, phishing signals, and suspicious patterns buried inside all that activity. Then it adapts as attacker tactics change. GenAI pushes the loop further by simulating new attacks, generating synthetic training data, and exploring threats that may not have appeared yet. Finally, it can support more tailored responses. So the flow is observe, detect, adapt, simulate, and respond. Pretty powerful, right? But here's the practical distinction. Traditional AI is especially strong at recognizing known patterns, while GenAI helps security teams rehearse for the unknown. The result we want is simple: detect earlier, test harder, and respond faster, without removing human judgment from high-impact decisions. Okay, this is the tension at the heart of the topic. GenAI is a dual-use technology. On the defensive side, it can simulate sophisticated attacks, create synthetic training data, spot subtle manipulation, and automate tailored responses that can make security teams faster and better prepared. But flip the same capability around, and it can generate highly convincing phishing, scale deepfakes, probe new attack paths, and help malicious actors adapt. The technology itself doesn't choose a side. Intent, access, design, and controls shape the outcome. That's why the safeguards along the bottom matter so much. Human oversight, privacy protection, testing, transparency, and clear responsibility. We're not trying to slow innovation down. We're trying to give it guardrails strong enough to capture the defensive value without ignoring the offensive risk. So how do we make responsible decisions when the technology is this powerful? The chapter gives us 6 ethical lenses. First, bias and fairness. Who benefits and who might be harmed? Privacy asks what data is collected, inferred, or exposed. Transparency asks whether people can understand the system's decisions and limitations. Accountability asks a deceptively simple question: who owns the outcome when something goes wrong? Malicious use forces us to imagine how the capability could be weaponized. Equity and access ask whether the benefits reach everyone, or only people with the most resources. And underneath all 6 is human autonomy. People need meaningful control, especially when decisions affect safety, opportunity, or rights. No single checklist solves everything. The real value comes from using these lenses together, early and continuously. Let's close with 3 active verbs: innovate, secure, and govern. Innovate, because GenAI can create genuinely useful capabilities. Secure, because those capabilities operate in a world of evolving threats and possible misuse. And govern, because human rights, accountability, transparency, and access cannot be afterthoughts. The chapter also reminds us that this is global. Different regions are developing different rules, but organizations still have to make responsible choices right now. Regulation may evolve slowly. Technology definitely won't wait. So, the final principle is to harmonize innovation with responsibility. Trustworthy GenAI is not just a high-performing model. It is a system designed with security, ethical judgment, and human oversight from the beginning. That's the foundation we'll carry into the chapters ahead.